Okay, so we were calculating our question here is 0.06 divided by 2. This is going to give us 0.03. We are going to add 1 into this and then we will raise it to the power 2. Now we are going to inverse this function, the multiply 1000 and 942.62 is our answer. 942. 942.60 is our answer. Now again, uh, let's calculate for the frequency where it's being quarterly compounded. So if it's been quarterly compounded, so we are going to divide 0.06 divided by 4. We are going to add 1. And then now we are going to raise it to the power 4 using yx. This is going to be 1.06. Now we are going to inverse this and now we are going to multiply this with 1000. So this is going to give us 942.18. 942.18. So I hope then you can now observe the difference here. 942.18. And similarly for monthly and daily, if we do the calculations, so for monthly, it's going to be 941.91. And for daily compounding, it's going to be 941.77. And the difference here is because of the increase in the frequency. So this is the important and the main crux here, which you need to pay attention to. After this, we are starting with compounding frequency, which is if we have a continuously compounding frequency, so how we are going to solve those kind of questions. So when the compounding frequency increases from, I mean, when the compounding frequency reaches to a point where it's being compounded continuously, this is associated with holding period term, then can be calculated using natural logarithm, and ln represents log, natural logarithm, and we actually have a formula for this in our I mean the calculated calculates this for us. We do not have to uh, we do not require any log tables for this. This is actually a very simple formula here if you pay attention. So ending and the beginning value, 1 plus holding period return, log of ending and the beginning value. So simply put, let me just show you how we calculate these questions. How do you apply this formula? So let's take an example. Let's take this example where uh, a stock was purchased for $100 and sold 1 year later for 120. Now calculate the investor's annual rate of return on a continuously compounding basis. So formula was log of 120 ending balance and beginning balance of 100. So this is going to give us, I'm sharing my screen. So it's very simple. We divide 120, we divide it by 100. This is going to give us 1.2, and we are going to simply press ln, log function. And this is going to give us 0.18. This is simple formula. We are going to multiply this with 100. This will give us a percentage of 18.23. 18.23 percentage is the investor's annual rate of return on a continuously compounded basis. So if the return, so now we have given numbers. And for example, let's assume if there was a return given to us, holding period return, if holding period return was given to us, let's assume a 20% holding period return or a 30% holding period return was given to us. So how we will do this in the calculator? Simply, we will go to our calculator. We are going to add 1 plus zero point 0.2 if the return is 20%. Click on ln, it's going to give us 0.18. We multiply this with 100. This is going to give us 18.23. If the return is 20%, 18.23%. And similarly, if the return is 30%, so we are going to add 1.3. This is the return. We are going to simply click on the ln function, log function. This is going to give us 226. And now we multiply this with 100 to convert this into percentage. And this is going to give us a return of 26.24 percentage. And this return is the holding period return based on holding period return. So we have calculated the continuously compounded returns here, 26.24. 26.24 percentage. Now let's go back to the formula. This was the formula, log of 1 plus holding period return and log of ending value and beginning value. We divide the ending value with the beginning value and log of 1 plus holding period return. So I hope these four formulas are clear. Now let's go to our question and answers. There are somewhat around 8 questions, and let's just quickly discuss these questions. So question number 1 is stock increased in value last year, which will be greater? It's compounded, it's continuously compounded, or it's holding period return. And we just discussed this. The holding period return, if it's 20%, the compounded return is going to be lesser. The annual compounding return is going to be lesser. And this is one property. And this is how the CFA Institute actually asks you a question. So you need to pay attention. So this was actually a trick. This question was very tricky. So unless until you have a holistic approach, a holistic knowledge of things, you will not be able to answer these kind of questions. So understand this thing. The stock increased in value last year, which will be greater? It's continuously compounded or its holding period return. And holding period return is going to be larger than the continuously compounded return. To answer to this, it's the holding period return. The right answer is holding period return. So if this question confused you, then it's a good thing. Now you are paying attention. Question number 2 is stated interest rate is 9% and compounded result is an effective annual rate closest to. You can look at- So a stated interest rate of 9% compounded continuously results in an effective annual rate closest to stated interest rate of 9% compounded continuously. So we just discussed about this formula. So we just discussed about this kind of question, but here it's the stated annual interest rate, not holding period return. It's not stated here. And to solve these kind of questions, we need to use another different formula, which is e raised to the power r minus 1. So if we apply this formula here, so stated annual rate is 9%. I'm sharing my screen again. Stated annual percentage is 9%. So 0.09 second, we need this function here, e to the power x. So we press on second, we press this function. So and see there here, it's once I click second, this activates the second function, a second key. Then I press e to the power x. This is going to give me 0.09. We subtract 1. We multiply it with 100. So this is going to give me 9.42, 9.42 percentage. Now this actually was a new formula which we have not discussed previously, and this was not the part of notes. So somehow I skipped this thing. Maybe this was part of further readings. E to the power r minus 1. So what we did is 0.09 on the calculator. We pressed second key. We pressed e to the power x second key on the calculator. Then we pressed e to the power x key on the calculator. This gave us 1.09. Then we subtracted minus 1 out of it. We multiplied it with 100 to convert into percentage. And yes, these questions are tricky, and that's why the passing percentage rate is not so very high, and that's why the CFA charter is very much valued uh, in the field of finance because it's not very easy. It's that's why how the CFA Institute actually it brings value to your time, to your efforts. Okay, so now next question. For a given stated annual rate of return compared to the effective rate of return with discrete compounding. So one is discrete and another is continuous. So discrete compounding is opposite of continuous compounding. For a given stated annual rate of return compared to the effective rate of return with discrete compounding, the effective rate of return with continuous compounding will be if we are discretely compounding or if we are continuously compounding. The higher the frequency of compounding leads to higher effective rate of return, and the effective rate of return with continuous compounding will therefore be greater than any effective rate of return with discrete compounding. So here, the effective rate of return with continuous compounding will be higher because with increase in frequency, the effective rate of return also increases. Okay, so I hope this is clear. Okay, now let's talk about, give me a moment. Now let's talk about question number four. So question number four is uh, it's relatively easy as compared to other questions. So the stock pays no dividend and it's currently being priced as 42 euros. 1 year ago, the stock was 44.23 and the continuously compounded rate of return is closest to what? So we just discussed this kind of question in our uh, example. So simply continuous compounding log opening closing 44.23, and you can use the calculator function to. Okay, so 1 year ago the stock was priced at 44.23. So this changes everything. So the stock is now currently being priced as 42 and then previously it was priced as 23. So this is the beginning and this is the ending. So closing and this is the opening. So this is actually representing a loss in the stock. And I hope now you've understood how to use the calculator effectively. You can use the calculator to solve this question. Now, question number five. So question number five is over a period of 1 year, an investor's portfolio declined from 127 to 108. So here we are also given numbers. Decline from 127 to 108. What is the compounded rate of return? Again, the portfolio has declined in value and we are given numbers. So just like the above question of continuously compounding, log of closing, opening, divided by 108, 427 log. And result, this will give you the answer. You can you can try using the calculator and this will be very effective for you to learn calculator functions also. Now let's go to question number six. The continuously compounded rate of return that will generate 1 year holding period return of 0.0 minus 0.65 a loss of 6.5 6.65 is closest to what? So the question here is continuously compounded rate of return. The continuously compounded rate of return that will generate 1 year holding period return of 0.065. Okay, 6.5. So here simply the formula was log of 1 plus minus 0.065. And when you solve this, this will give you. Let me share my screen, share my calculator. I'm having some issue with my calculator, no problem. So if you solve this, this is going to give you somewhere around minus 6.7 percentage, and the option will be C. Okay, now let's move to question number 7. So question number 7 is again based on continuously compounding rate of return. So most of the questions where your concepts are being tested, these are continuous. These are about continuous compounding. So again, I hope this will stock decrease from 90, decrease from 90 to 80. A stock decrease from 90 to 80. The continuously compounded rate of the continuously compounded rate of return for the period will be equal to this. And when once you calculate this, option A will be the answer here. And finally, our last question. Given the holding period return of R, the continuously compounded rate of return is equal to what? Given a holding period return of R, the formula for compounding period return is option B, log of 1 plus R. Log of 1 plus R, and R represents the holding period return here. So that's pretty much it. And we have completed our LOS 1D. We have understood to interpret annualized rate of result measurements and continuously compounding rates and describe their appropriate uses. So I will see you in next reading. Reading 1D. All right, thank you.